Hello, welcome to another practical change of subject series. In today's series 2, we would be solving a very engaging question in mathematics, change of subject, right? So let's quickly delve into the series, right? So our question for the day is make T the subject of the relation, right? So our given equation is Q equals to the square root of the fraction R over the fraction 1 over S plus the fraction 1 over T, right? So we are supposed to make T the subject of the relation, right? So based upon the preamble of our question, our K is given as the square root of the fraction R over the fraction 1 over S plus the fraction 1 over T. Okay, so when you have a question like this where it involves square roots, right, the first thing you have to do is to eliminate the square roots by squaring both sides, right? So you square both sides of the equation, or the equation, to remove the root square, right? Or the square root, the root square, right? So, and it's generic. Whenever you see a root square or a square root in mathematics, change of subject, what the first thing you have to do is to square both sides to remove the root square or the square root from the equation, right? So in doing so, we are going to have our equation to be Q square equals to the root square of the fraction R over the fraction 1 over S plus the fraction 1 over T square, right? So after stating our new equation, what we have to do is to eliminate, okay, the root square or the square root from the equation by cancelling out the square root. So this two will cancel itself one. It will cancel the square root, okay, thereby eliminating the square root. So we are going to have our new equation to be K square equals the fraction R over the fraction 1 over S plus the fraction 1 over T, right? So what we have to do is to multiply through by the LCM, right? So our LCM here is the fraction 1 over S plus the fraction 1 over T, right? So this LCM will multiply through each side of the equation. So it will multiply through the fraction R over the fraction 1 over S plus the fraction 1 over T, right? And it will also multiply through K square, okay? So we are going to have our new equation to be K square multiplying the fraction 1 over S plus the fraction 1 over T, all in bracket, equals R equals the fraction R over the fraction 1 over s plus the fraction 1 over t multiplying the fraction 1 over s plus the fraction 1 over t, all in brackets, right? So every number is divisible by 1, right? So this k square is divisible by 1. Okay, so k square multiplying the fraction 1 over s plus the fraction 1 over t, all in bracket, would be stated as k square over 1 multiplying the fraction 1 over s plus the fraction 1 over t, all in brackets, right, equals to the fraction r over the fraction 1 over s plus the fraction 1 over t multiplying the fraction 1 over s plus the fraction 1 over t. So in doing our multiplication, right, this fraction 1 over s plus 1 over t will cancel out itself with the fraction 1 over s plus 1 over t here. Okay, leaving our equation to be k square over 1 multiplying 1 over s multiplying the fraction 1 over s plus the fraction 1 over t, right? So here, okay, in solving for the fraction 1 over s plus 1 over t, we do what we call cross multiplication. Okay, so you have to cross multiply, right? Cross multiplication. Okay, so here, okay, so here, when you are cross multiplying, okay, let's take this fraction 1 over s. Okay, this one here is the numerator and this s here is the denominator, right? So in cross multiplying, okay, the denominator on your right hand side, which is 1 over t, the t here, okay, would multiply the numerator, okay, on the left hand side, okay. Also in similar trajectory, okay, the denominator on your left hand side would multiply the numerator, okay, on your right hand side, right? And when you are done, both the denominators would multiply each other, right? So s multiplying t, right? So that's how cross multiplication is done. So the denominator on your right hand side would multiply the numerator on your left hand side, and the denominator on your left hand side will multiply the numerator on your right hand side, and both denominators would multiply each other afterwards, right? So we are going to get our new equation to be k square over 1 multiplying, now 1 times t is t, right? 1 multiplying s is s, right? S multiplying t is st, right? Equals r, as explained earlier on. Okay, so in doing our multiplication, right, k square would multiply t plus s, right? And 1 will multiply st. So when you are multiplying fractions, here we don't do cross multiplication, right? We multiply, the numerator would multiply the numerator on the other half, the denominator would multiply the denominator on the other side. Okay, so the numerator k square will multiply the numerator t plus s, and the denominator 1 will multiply the denominator st, right? So that is well understood. So we are going to have our new equation to be k square, our new equation to be the fractions k square multiplying t plus s over st equals r, right? So this r here, every number is divisible by 1, so it has an invisible number 1 here, right? Okay, so when you have an equation like this, what you have to do is you cross multiply. But this form of cross multiplication is quite different. Okay, so here you only, right? If the equation is the equation that you are multiplying, right, is on different half of the equation, right? You cross multiply each side without multiplying the denominators, right? So you cross multiply with the numerators and the denominators without multiplying the denominators afterwards, right? So this one will multiply k square times, or k square multiplying t plus s, all in brackets, and this st will multiply r, right? So we are going to have k square multiplying t plus s, all in brackets, multiplying 1, okay, and st would also cross and multiply r, okay, right? So we are going to have our new equation to become k square multiplying t plus s, all in brackets, times 1, or multiplying 1 will give you the same k square multiplying t plus s, all in brackets, because every number multiplying 1 is that same number, right? And also r multiplying st will give you str, right? So we do some expansion afterwards, right? So we have our new equation to be k square multiplying t plus s, or in bracket, equals str, right? So from here you have to expand, do some expansion. So in expanding, k square would multiply t to become k square t, right? And k square would multiply positive s, right? They are all positive numbers, to, to give us positive k square s, right? Equals str. So we have our new equation to be k square t plus k square s equals str, okay? So based upon our question, right, we were asked to make t the subject of the relation, okay? So when we check our new equation, which is k square s equals, when you check our new equation, which is k square t plus k square s equals str, right, you could realize that t is common in k square t and str, right? So what you have to do is to group like terms, okay? So you have to group like terms, and in grouping like terms, right, you shift those variables that contain t to one side and those without to the other side, okay? So here we maintain k square s, which is a positive number, positive k square s, right? And shift k squared t to the other half of the equation. Now, k squared t, right, is a positive number, and when it crosses the equal to sign, it changes its form, right, to become a negative number. So any number, okay, when it crosses the equal to sign, it will metamorphose or transform or change its formation to a different set of variable, right? So if it's a positive variable, it will change to become a negative variable. If it's a negative variable, it will change to become a positive variable. So this variable here, k squared t, is a positive variable, so it will change its form when it crosses the equal to sign to become a negative variable, right? So we have our new equation here to be k squared s equals str minus k squared t, right? So here we have to factor out the common factor, right? So among str minus k squared t, the common factor is t, right? So we factor out t here as demonstrated here, right? So we factor out t here. And among t, right, which number in the world can multiply t for us to get str? And the only number you can get in this world is sr, right? So among t, which number or which variable in the world can you multiply for you to get negative k squared t, right? And the only number or the only variable in the world is negative k squared, right? So we are going to have our new equation to be k squared s equals t multiplying sr minus k squared, all in brackets, right? So we have to do some cancellations out, right? So now t multiplying sr minus k squared, all in brackets, is a dependent variable, right? So t is dependent on sr minus k squared, all in brackets, right? And in doing so, we want to make t the subject of the relations. That means we want to make t an independent variable that is like supervising the entire equation, right? So in doing so, we have to cancel out the dependent, right, which is sr minus k squared. Okay, and in mathematics, whatever you do for the right hand side, you do same for the left hand side, right? So you have to cancel out at like on both sides of the equation, right, with sr minus k squared, right? So that is what is demonstrated here. So we will get our new equation to be k, the fraction k squared over sr minus k squared equals to the fraction t multiplying sr minus k squared, all over sr minus k squared. So sr minus k squared will cancel itself out one. It will cancel the same sr minus k squared in the numerator, leaving t to be the subject of the relation. So we are going to have our t, okay, to be t equals to the fraction k squared s over sr minus k squared, right? So that's our final answer. Thank you so much for watching today's video. Kindly do well to subscribe for more. Thank you. Bye.